Today we're working with determinants and Cramer's rule. And determinants help us use Cramer's rule. And what Cramer's rule does is solve systems of equations with matrices instead of elimination or substitution. Okay? So the first thing that we're going to be doing is finding a determinant of a 2 by 2. Remember, a 2 by 2 is rows by columns. So we've got 2 rows and 2 columns, okay? So 2 by 2, and here are the directions per se. We multiply the two numbers that are on the main diagonal, which is this one right here. That's the main diagonal. Then we subtract from it the numbers on the minor diagonal. So A times D minus C times B. So you can see in the worked out determinant here, we've multiplied 3 times 4 minus 5 times 1. Very, very simple. So we could do -2, -9, 3, and 4. And our determinant would be -2 times 4 minus 3 times -9. So -8 minus -27. And then, of course, -8 plus 27 gives us a determinant value of 19. So 2 by 2s are very simple. Just remember, it's the major axis minus the minor axis. If you do it the other way, it will be incorrect. Okay, so we've got 3 by 3s. Now, doing anything larger than a 3 by 3 is left to more upper class math classes because you need to use cofactors and cominors, and it's a very long, drawn out, crazy, ridiculously tedious job. So we go as far as a 3 by 3, and that's it. So in order to do the determinant of a 3 by 3, we need to be able to match all of these numbers here on the diagonals. And as you can see, we are missing quite a few of those numbers. So the way that we make up for that is to pick up the first 2 rows. I'm just going to leave it in white and rewrite them. Pick up the first 2 columns and stick them to the end. Okay, now when we want to do our major, we've got these 3 that go this way and everything has a number, and then we would have these 3 go this way and everything has a number. Okay, so let's start with that. So 1 times 1 times 1 is 1. So we don't even need the parentheses. So 1 plus 0 times 3 times 1, which is 0, plus 2 times 3 times 1, which is 6. And then from that, we are going to subtract the minors. Okay, so going up this way, 1 times 1 times 2 is 2, plus 1 times 3 times 1 is 3, and then, of course, a 0. So the determinant is 7 minus 5, which is equal to 2. So the rule to find the determinant of a 3 by 3 is you pick up the first 2 columns, stick them on the end, and then go about your major minus minor. Okay, so the thing that I guarantee that some of you will mess up is that within these sets of parentheses here, you add all the products of the major, which is right there. I should probably just change color since you can't see that. You add all the products of the major, you add all the products of the minor, and then you subtract those sums. Okay? So that is a 3 by 3. Now we use that idea for Cramer's rule. Okay? So the first thing that you need to do when you are solving a system using Cramer's rule is to create the matrix. So we'll have X and Y, and then we have two equations. So one equation and two equations. So I'm going to get rid of all of that, and you will be able to follow. So under the X column, we have 4 and 6. Under the Y column, we've got 3 and -1, okay? And that is the matrix for the X and the Y. Then we've got a solution matrix that carries the 8 and the 1. Okay, so what we need for Cramer's rule is to find the determinant. So we'll just call that matrix A. Okay, we'll call that matrix A. We need to find the determinant. Then we need to find the determinant for the X terms. And then we need to find the determinant for the Y terms. Okay, and this example is going to show you how to do that. So the determinant, we've got our matrix right here. We're going to find the determinant of that matrix. 4 times -1 is -4 minus 6 times 3, which is 18. So the determinant of the main matrix is -22. Well, here, you know what? I don't really have enough room. We'll write those in a different place. -22. Okay, now what we're going to work on is finding the X determinant. Okay, now the way that we do that is, we already stated that that first column there is our X column. The way that we find the X determinant is we are going to replace the X column with the solution set, 8 and 1. And then the Y column is the same. Okay. Now what we'll do there is find the determinant. So we're looking for the X determinant of A. We took the X column and replaced it with the solutions. And find the determinant. 8 times -1 minus 1 times 3. And that gives us that the X determinant is -11. Okay, then we will do the exact same thing with the Y determinant. We will keep the X column the same as the original, but this time we're replacing the Y column with the solutions. Okay, so 4 times 1 is 4 minus 6 times 8 is 48. Which gives us that the determinant for the Y matrix is -44. Okay, so all of these values right here come from determinants. The main determinant comes from the main matrix. The X determinant comes from replacing the X column with the solutions. And the Y determinant comes from replacing the Y column with the determinants. And then the way you solve, you're going to put the X determinant over the main determinant. So, negative 11 over negative 22 tells us that the x coordinate is 1/2. And then we'll do the same thing with the y. The y determinant over the main determinant is negative 44 over negative 22, which tells us that the y value for that system is positive 2. Okay? And you would do that same thing with a 3x3, 3 equations, 3 unknowns. You would use your 3x3 determinant, the rules for that, and to find the x determinant, replace the x column with the solution column. To find the y determinant, replace the y column with the solution column. To find the z determinant, replace the z column with the solution column. And you would expand each 3x3 into a 3x5. Okay? All right. And the last thing that we can use this idea for is finding the area of a triangle. So we know that the area of a triangle is A equals 1/2 times the base times the height. Well, the determinant is going to take care of that base times height. Okay? So what we're going to do is set up the matrix for each one of those vertices. X in the first column, Y in the second column, and the third column is always, actually, let's do it the other way. We'll put X and Y, we'll put X and Y on the, we'll put X here and Y. And then the bottom row is always ones. Okay, it just makes more sense. And this follows the setup in the book. So all of the x coordinates, starting at -3, then 1, then 2. And then the y coordinate that goes with -3 is 1. The y coordinate that goes with the x of 1 is 3. And the y coordinate that goes with the x of 2 is 1. Now we need to find the determinant of that. So we will do this one, okay? We will do this one. So we'll pick up the first 2 columns and rewrite them at the end. Okay, that's a little bit, let me write them a little bit closer. They're kind of, so -3, 1, 1, 3, and 1, 1. Now we can find our determinant, okay? -3 times 3, that's -9, plus 1, plus 2. Okay, then going the other way. I'm going to change color. Going the other way, we've got 1 times 3 times 2 is 6, plus 1 times 1 times -3 is a -3, plus 1 times 1 times 1. So remember, you add your products, your major products, your minor products, you add those, and then you subtract those sums. So -9 plus 3 is -6, minus 6 minus 3 is 3 plus 1 is 4. So that gives us a -10. But if you look at your area formula for your triangle, you have that area is equal to plus or minus the 1/2 times the determinant, because you know that area is a value and it is not negative. Okay, so the area will be the negative of that -10. So area will equal 1/2. So we'll say -1/2 times -10, which will end up giving us a +5. Okay? There we go. So a quick recap. Kramer's rule, when you're solving for x, you find the x determinant. Replace the x column with the solutions. When you're finding the y determinant, replace the y column with the solutions. Find each determinant, and then you divide. The x determinant by the main to find x, the y determinant by the main to find y. Very, very cool stuff. Okay, get to work.